Okay, perfect. So, hello, I'm Stavros Charismiadis. I work for Focus Innovation and Services, and today I will present you how we leverage a specific feature of CAPIF called the vendor extensibility feature, and how we expose CAMARA APIs more efficiently with that feature. I will start with a few things and a very short recap on the CAPIF architecture. I will go on with the motivation, what motivated us to go through that direction of the vendor extensibility feature. Then I will explain what is this vendor extensibility feature, and hopefully I will showcase a demo how this feature works. So, a small recap on the CAPIF architecture. I think also the previous presenters mentioned that. I will go through it very briefly. The most important element is the CAPIF core function, which hosts all the necessary functionalities of the API management that CAPIF does. Is authentication, authorization, monitoring, and the capabilities to publish and discover service APIs. Then the second important entity is the API provider, which is the entity that hosts the API and gives access to it through the CAPIF. And last but not least is the invoker, is the entity which consumes the APIs that the provider publishes. The key functions, let's say, of the CAPIF are register and remove entities, actually providers and invokers, publish and discover APIs, authenticate and authorize the invokers towards the API providers, and monitor API invocations. In this presentation, we will focus mainly on the publish and discover APIs, because the feature that we're going to present concerns these two functionalities. So what motivated us? The discoverability of the CAPIF is, I think, the most known and most important functionality of all. Until now, the CAPIF specifications assume that the CAPIF core function can give, let's say, to the invokers information about an API, mainly connectivity information, such as the IP, the port, or some security, let's say, information. But some other kind of information, such as the structure and the schema of the body of an API, are not given by the CAPIF, but the invoker has to search for it on external resources, such as Swagger servers, let's say. So it gets some information from the CAPIF, and some information in order to be able to do some APIs like post, like update, like patch, it has to get them from external sources. So there is an intermediate step that is depicted here on the right hand side with the step 2 that the invoker has to do. Get all the information either from the CAPIF or the external, and then then access the API that discovered from the CAPIF. Actually, this intermediate step was a key point for us to try to find a way to enhance the CAPIF discovery process by giving the Discover API of the CAPIF the capability to return all the necessary information to the invoker, both the connectivity, let's say, information and the body structure information. This, of course, results in making the life of the invoker more easy. In what way? when the invoker in that case gets the overall information from API, it can directly on the runtime of the program that works like the invoker to make the API call. This, however, has also another benefit. It provides actual interoperability. Someone here might say that, okay, we have interoperability as we are talking about standardized APIs. However, even the standardized APIs may have different versions, or different providers may have different implementations, or enable different fields or functionalities inside these APIs. So even in standardized APIs, it is a benefit to have a correct structure of the body of the API you want to call. Another thing that motivated us was the actual architecture and the use cases of the project that we made this implementation, which is the envelope project, a StreamD SNSJU project from Call One. Some short things about the most important, let's say, layers of the architecture. On the top level are the CAM applications. Actually, CAM applications have to do with applications concerning mobility aspects, like cars, like etc., and are working as the applications that want to boost their functionality by using 5G and beyond 5G infrastructure. The second layer is the envelope APIs layer, which acts as a translation layer between the complex 5G, beyond 5G interfaces, and tries to translate them on a more user-friendly interface. And then are the envelope enablers layer, which is the layer which directly communicates with the infrastructure APIs. And here is exactly where CAPIF is positioned. CAPIF on the scope of envelope in this case, because we also saw on the morning another presentation that for the envelope project that position CAPIF also on a higher level. In this presentation, we're focusing on the standardized, let's say, position as an API manager that exposes infrastructure APIs, and on this infrastructure APIs category are either the network APIs, the 5G or beyond 5G network APIs, or edge APIs or far edge APIs. So this is where the CAPIF is positioned. And just here, a translation of the figure we saw on a previous slide, which is on the left-hand side, translated to the envelope architecture. As the time passes, I will go through it. I will pass through it, as we have already said that. So let's focus now on the CAPIF APIs that this new feature that we're going to talk is about. The first is the publish service API, and it's the API, the CAPIF API that gives the ability to an API provider to publish its APIs. Okay. Here on the right-hand side, you can see the information that the API provider has to give to the CAPIF in order to publish the API. A small notice, you can also see that there is no mention about the body structure. Okay, so it is, as we said before, the API provider gives only some connectivity, mainly information. Okay, and then we have the discover API, which is used by the invoker in order to get back which APIs are exposed in the trust domain by the API providers. So here is the limitation. As I showed you before, there's no description about the body structure of the APIs. And this has, let's say, a twofold limitation. It limits also the usability from a third party and non-standardized APIs, because CAPIF, as we saw also on other presentations, can work as a general API manager. However, here is a limitation. There is no standardized API for some custom API service. This is the one page, and the second is what we also said before, that even for the standardized APIs, versions and implementations among the providers may vary. So practically, an invoker, by getting some API information from the discover, can make GET HTTP requests, but cannot make POST or PUT or PATCH requests, since it has no information on the body, or not exact information on the body. So this is the idea we had, to find a way to give also that information of the body request of its API. And here is where the vendor extensibility jumps in. The vendor extensibility is a defined feature of the CAPIF, which gives the opportunity to an API provider to extend the model of the service API description. If you remember from a previous, from this slide, these are the information that the CAPIF specifies for its API description. So with the vendor extensibility feature, a provider has the capability to add some more fields on that table, some vendor specific fields. And this addition of the vendor specific fields is also standardized in a very specific way. You can show on the left-hand side that the field, let's say, has a specific naming scheme, which includes the vendor-specific keyword and a description of the vendor, either with the IANA assigned code, either with the domain name, or with the URN description for the publish API. And also this feature can be enabled on the Discover API. How? By a specific naming scheme. I will show you that on the demo also, but when you add a vendor specific parameter, you do it that way, vend spec and the query parameter name as a key, and as a value a JSON field with two subfields, let's say, the target and the value. So, as a project, we contributed to the Open CAPIF SDG by implementing the whole vendor extensibility feature, as you can see also with from the figure, and we tried to combine these two concepts. The challenge that I described to you before, and the capabilities of the vendor extensibility feature. So we proposed a way to expose the body structure of an API by using the vendor extensibility feature. How? By adding a new field with that format, vendor specific URN body, the name of the resource, and the keyword info. And the value of this field would be a JSON format field with three options. Either by describing the body with a URL link, for example, to a Swagger UI server, or by defining or giving a JSON describing the body, or by a reference to a specific document. So I will show you also on the demo, but here is how we described the body of the CAMARA quality on demand API. And now I will go through the demo. So I have locally deployed the CAPIF. For the sake of simplicity and time, I have already created with the Postman interface the provider and the invoker. Okay, and now I will just execute a publish and a discover API to showcase you the vendor extensibility feature. So here it's the publish API, and the provider wants to publish a QOD API with the protocol, with the data format, with the IP address, with the port, etc., and also has the ability to expose also the body. Here we use only the two of the three options. The URL, this is a valid URL to the Swagger UI of the CAMARA QOD API, and an example of the schema of the API. So hope it will work. Let's cross fingers. Okay, it worked, and we can see not only the standard fields, but also the vendor specific fields. So the invoker, as a result, this is the discover API of the invoker. And now, in order to enable the vendor extensibility on the discover API, first of all, we have to add this field, the supported feature field, with this specific value to this actually enables the vendor extensibility feature in the discover API. If this is not a part of the URL, I will show you later, it will fetch some APIs, but without the vendor specific field. So first of all, we enable the vendor extensibility feature, and then we add the vendor specific parameter. Here we want to ask for a QoS profile to be equal to voice. And we have a JSON with target and schema. If you remember from the body of the post, here is the quality on demand info, and then we have URL and schema. So what we say is look on the schema for a QoS profile field, and we want it to be equal to voice. So making that, we also get the API with the vendor specific fields included. Just a small experiment. If we delete these two, it will again fetch the API, but without the vendor specific fields. And I think I have ended my presentation. Thank you all, and I'm open to questions.